Example problem 20.5, sound energy at a construction site, which is on page 753, says this: the intensity of sound at a construction site is 0.10 watts per meter squared. If the area of the eardrum is 0.20 centimeters squared, how much sound energy is absorbed by one ear in an 8-hour workday? So we've got intensity 0.10 watts per meter squared. An area of 0.20 centimeters cubed, and a time of 8 hours. One thing you should recognize right away is that we've got two units that are not in the, or two factors that are not in the units that we usually like. We need to be in seconds, we need to be in meters, we need to be in kilograms. 0.2 centimeters squared. The centimeter squared can throw some people off because you essentially have to convert it twice. You can't just move the decimal like you normally would. So 0.2 centimeters squared, what would that be in meters? Well, you'd have to do it twice. To get to square meters, where it's 100, 100, 1 to 1 to cancel all that out. Basically saying instead of moving 2 digits, since it's squared, you have to move it 2 digits twice, or you have to move 4 digits. So we end up with 2.0 times 10 to the negative 5th meters squared for our area. Our time is not in seconds, it is in hours. 8 hours, we'd like that in seconds. You can go hours to minutes to seconds if you'd like, or if you know that 1 hour has 3,600 seconds, you could do it that way as well. You end up with lots of seconds, 28,800 seconds. Now that we've got our units where we need to be, we can go ahead and actually start the problem. We're wondering about how much energy is absorbed by that eardrum in an 8-hour workday. Well, intensity is the change in energy, or the amount of energy, over the change in time, or the amount of time, multiplied by the area. And since we are interested in finding energy, we should try to get energy by itself. To do that, I would multiply both sides by delta T and A. So I end up with delta T times A times intensity being equal to delta U, or total energy. Now it's just plugging the values in. 28,000 seconds times an area of 2.0 times 10 to the negative 5th meters times an intensity of 0.10 watts per meter squared is going to give us our change in energy. That should be 28,800 seconds. I made a mistake. It ends up being that the amount of energy absorbed is 0.058 joules, which doesn't sound like much, but over time can add up. And the smaller the ears, the smaller the eardrum, the more that this can affect somebody.